Good morning, guys. How's it going? So today I have for you the angle addition formula for, sorry, let me close this menu real quick. I'm going to show you guys how to derive the angle addition formulas using this proof triangle right here. So this diagram, I labeled each of the vertices. It's actually 3 triangles. You have this one. This one should be blue, but it overlaps with another triangle, BFC. And then you have ABC. So you have ABC, BFC, ACD. ACD is right here. And this length right here, this hypotenuse of ABC is equal to 1. I'll write that for you. Alright, so if we add 2 angles, you have angle A, angle B, we add them. The x distance is AE, the y component is BE. Now we wanna get those with, I'll start by writing cosine x. So x plus y, or in our case out A plus B, but I'll use x plus y because that's more generic, is equal to, it's going to be, you can't find AE, which is what we're trying to find, by any triangle, but if you find AD, right, this length here, and then you find AE or ED and subtract it, then that'll give you AE. So it's AD, that long one, the long length segment, minus ED. When we do this proof, we won't actually find ED directly. We'll be able to find FC from this triangle, and because this is a rectangle right here, FC is equal to ED. So you can write that equivalency statement right here. All you have to do is say FC is equal to ED. And likewise for FE, we won't be able to find FE, but we'll be able to find CD, and they're opposite sides of a rectangle. So that means that it's going to be FE is equal to CD is your other equivalency statement. So I'll write that right here. EF is equal to CD. All right, so then we'll do the same thing for sine of x plus y. We're going to add FE and BF. The reason why we're adding and not subtracting is because to find this segment here, we have to take AD minus AE because we can't find minus ED, sorry, to find AE. And then, but for here, we add them because the opposite of this triangle, and this is the adjacent. So if you look at the line segments, those are what you have to put together to find, basically match the triangle you'd get from adding those 2 angles. So this is going to be BF plus EF plus BF. Okay, we're going to start with ABC, or BFC because, ABC because this one's the easiest because the hypotenuse is 1, so when you do sine, of alpha, that's going to be opposite. That's going to be BC over 1, which is just BC. And then cosine of that is, this is our angle A, adjacent is here, AC, and our hypotenuse is right here, A to B 1, so that'll just be AB. Cosine A equal to AB. Okay, good. Over 1. You can omit the 1, but I'm just trying to clarify. And then for ACD, sine of beta. So if this is our angle B right here, opposite is CD, hypotenuse is AC, so that's CD over AC. And then for cosine of b. That's gonna be, I think I made a mistake right here. This one should have been cosine, so I'm just gonna recall that cosine, or rename it cosine. And this one should be sine. This is cosine, and then this one is sine. Okay, and then cosine will be ADAC. Because adjacent is AD and hypotenuse is AC. Alright, very well. And then BFC is this small triangle right here, and our angle A is right here. This is it's kind of hard to see, but this is a 90, 45, 45, because this line segment bifurcates BC to A. So sine opposite here is FC, hypotenuse is BC, so FC over BC for sine. And then for cosine, we have adjacent, which is BF over BC. Adjacent over hypotenuse, BF over BC. Alright. Now that we have all those, all we basically do is plug them into here. Into this formula right up here. Not formula, but geometric equation, I guess, we've come up with for the proof. So AD is right here. We want to solve for AD, so we multiply by AC. So that means AD is equal to AC cosine B. That was bad writing, my bad. AD to and then so AC, we know what that is, that we can look at AC. Where's AC at? AD comes to AC, and then we said AC was hypotenuse AC. That shouldn't have been AC on the ACD, that should have been for ACD. Pause this recording. Alright guys, sorry. I'm back. I found a mistake. When we did the ABC triangle, I wrote the wrong side of the triangle for the cosine. That one should actually be cosine. The adjacent is AC and it's over 1. So AC over 1. So that means when we plug in AC for here, it's going to be AC is equal to cosine A. So for AD, we can make the substitution right here. I'm only going to show this work for one of them because for the rest of them it's the same thing, and I think it's a pretty simple thing to do. Cosine A, cosine B. So we have AD now, we can put cosine A, cosine B. And then now we want to put minus because we're subtracting ED. ED is equal to, and then where's ED at on here? Oh yeah, we used the equivalency statement. You won't find ED, you'll use FC, and FC is equal to, ED is equal to FC, which is also equal to sine A BC. So sine A BC, and you know BC from over here is sine A. So we got sine A, sine B. After you do the substitution, sine A, sine B. why isn't my webcam on? No. Oh wait, is it even recording? Oh yeah, it's recording. Oh damn, it was recording all the time. Here we go. Alright, I'm back, guys. I did do an edit. I'm gonna start back up with sine. So sine FE, we know CD because of the equivalency statement. So I'll write that down here. We're using FE, but we have opposite sides of a rectangle right here, which is CD. And then that's equal to, what is CD? We know CD is right here. So multiply by AC, you get AC sine B. AC sine B. And then we know AC is cosine A, so that'll be cosine A sine B. And then BF is, where's BF? BF is, let's see. Oh, BF is right here. BF is equal to cosine A BC, so BF is equal to cosine A. This is my first video. I just got this new tablet. My handwriting will get better. Don't worry. Cosine A, and then BC said BC was sine A, so cosine A sine A. And then put that in here. So that'll make this cosine A sine B plus cosine A sine A, or BFC. Yeah, cosine B sine A. Alright, that's all I have for you guys today. If you want to know tangent, I'll actually show you tangent just because. Actually, there is no tangent for this one. I was thinking of the half angle formula. Have a good day. Great. They're great.